Hello guys, and welcome to another TKGgames tutorial. Today we're going to be solving quadratic primes, which is problem 27 on Euler. Euler discovered the remarkable quadratic formula n squared plus n plus 41 to produce 40 primes. And then the incredible formula n squared minus 79n plus 1601 was discovered to produce 80 primes for the values 0 less than equal to n less than equal to 79. The product of the coefficients is negative 79 and 1601, which is equals to 126,479, which is negative. Considering the quadratic form, n squared plus an plus b, where a is the absolute value of a less than or equal to 1000 and b less than or equal to 1000. So for here, we know that we have to go through negative 99 to positive 99, and here negative 1000 to positive 1000. Where n is the modulus, absolute value of n, blah blah blah. So find the product of the coefficients a and b for the quadratic expression that produces the maximum number of primes for the consecutive values of n, starting with the number with n equal to 0. So we know that we can optimize this by making b primes, because b's are the prime numbers. Okay, so if we look at this, they're b's. We can replace b's with prime numbers, so we can generate prime numbers for b here to optimize this problem, rather than going from negative to positive 1000. So let's go ahead and actually start solving this and coding it out. All right, so I'm just go ahead and create a Java class, and I'm just going to go ahead and Control V because I already copied that name of the thing. I'm going to shift this and let's create the class. All right, so now we have this. I am going to go ahead and first write the isPrime method. Do private static boolean isPrime. And I rewrote this over again to make it a little bit more cleaner than the older one that I got, by using hash set instead of just generating anything. All right, so if it's less than or equal to 2, just go ahead and return false. Then we can go ahead and create a list here, where list is going to equal new hash set, and I'm going to make this longs. And then we need the square root equal to the math square root, and just pass in the value, and it's a small one. All right, so next we need to create a for loop. We'll say for var v equals to 1 long, and v is less than or equal to the square root, do v plus plus. We're going to say if the value mod v is equal to 0, then we're just going to do list dot add v, and if the list dot size is greater than 1, then we're going to go ahead and return false. All right, and then we can return true here. All right, so the next thing we want to do is we want to go ahead and pretty much get the quadratic form for that formula that we would need to write, which is going to be this one here. All right, so we need a function for this. So this is going to be a private static long, and call this one quadratic form. It's going to take in a long n, long a, and long b. All right, and we can just do a return here, do math dot power, pass in n squared plus a times n plus b. Hopefully I got that right. And we have to do a cast here. So we're going to cast it to type long. Let me just make sure that I got the, so it's an, b, okay, so we're good. Alright, so next what I want to do is we actually want to go ahead and count the consecutive primes. Do private static long consecutive prime counter, and this is going to take in a and b. Alright, so what we need to do is count. So I'm going to say var n is going to equal to 0, and we're only going to stop when we find a number that's not prime. Okay, so we're going to say n plus plus. We're going to say if not is prime, and then we need that quadratic form. You're going to pass in n, a, and b. Then we're going to return the n because that's going to be the number that we're counting. Alright. Next what we want to do is we want to replace the b with all of the prime numbers. So we need to generate prime numbers. So I'm going to go ahead and generate that. So static lists going to be of longs. And let me import this. You can just press Alt and Enter. And then I'm going to call this one generate b primes. Alright, and we need a limit here. So I'm just going to replace everything with long since I started with long. So so what do we need? We need a list. So we need a list primes. It's going to equal to new array list integers. No, what? No. Longs. Okay, so we need a for loop here. So going to say for var v equals to 1l. V is going to be less than or equal to the limit uv plus equal to 2. That way we only get the odd prime, So this is not going to include 2. When I wrote this algorithm, I kind of guessed that 2 was not going to be needed, right? And it worked without the 2, so I'm not going to include the 2 there. Just kind of make the computation one less. All right. So let's go ahead and generate the prime. So we're going to say if is prime, and we're going to pass in v. Then we're just going to do list primes dot add v. And let's go ahead here and return the list primes. Now we have to do the counting. So we're going to do private static long max consecutive prime solution. And this is going to take in, should I pass the limit here? No, it's fine. I guess I could just you know what, let me just do it that way. So I'll do a long here and I'll pass in the limit. Okay, because we need to generate the primes, and I did that. So so first thing we need to do is we need to get the list primes. It's going to equal to generate list primes, and let's pass in the limit here. All right. Next we need some variables to hold the max product, and we need one to hold the max count. Okay. Alright, so next one to do is create a for loop, and we need to create A. So A is going to start at negative 999, okay? And it's going to be less than or equal to 1000. Alright, do A just like we did with the primes. Do that A plus equals to 2 because we're looking for the odd numbers, and I keep screwing up. Why do I keep doing that? Alright, so we need to create an inner loop for B. We're gonna do this for J. So we're gonna say J is gonna equal, we're gonna say there, J is gonna be equal to 0. J is gonna be less than the list primes, the size, and J plus plus. Alright, so right here, so B is gonna equal to primes dot get J. Then we need a variable for the current count. It's gonna equal to the consecutive prime counter, right? And we're gonna pass in A and B. And then we need to get the max count. So we're gonna say if the current count is greater than the max counter, then the max counter is gonna equal the current count, and the max product is going to equal A times B. And all we have to do now is return the max product. All right. So let me browse this over again because looks like I've been messing up a little bit. So it's not prime. N squared plus B. This is fine. Alright, looks fine to me. Alright, so let's go ahead and create main. Do S of T here, max consecutive solution. And we're just going to pass in 1000. All right, let's run this. And this is what you should get for this solution. All right, guys, this will be it for this tutorial. I'll see you guys in the next one. Have a good day. Bye-bye. Please like and subscribe to my channel.